All right, objective 5.1.2, given a one-to-one function, find its inverse. You've dealt with inverse functions before. You use them every time we solve an equation. If we've got an equation like 3x equals 6, you know what to do to solve that equation. You divide both sides by 3 because that's the inverse operation of multiplying by 3. Do that to both sides and you get the solution, which I really don't need to finish this one, I hope. But that's the idea of an inverse function, is what will undo a function. So suppose we have an inverse function like y equals 2x. We input a number like 1. We put a 1 in there for x, and we get a y of 2. We put 2 in for x, we get a y of 4. We put a 3 in for x, we get a y of 6. Okay, so that is our function. I probably should write f of x there instead of y, but they're really exactly the same thing. Now what I want is a function that will reverse the x and the y. I got a 2 out of that function. Well, what did I put in to get the 2? A 1. What did I put in to get the 4? 2. What did I put in to get the 6? 3. So finding the inverse function here for our ordered pairs is really, really simple. All we have to do is swap the x and the y, and that gives us our inverse function. Finding the rule can be a little more difficult. It's really not more difficult here. I think you know the opposite operation of doubling something is taking half of that thing. So our inverse function, which we write f, it looks like to the -1 power, but it means inverse, not a -1 power. Our inverse function is just going to be x divided by 2. Okay, really simple. Suppose we had a function g of x equals x plus 3. What do you think the inverse function would be? This is going to be a real shortcoming of doing business this way. I ask you guys a lot of questions in class. You're not going to be able to answer them here, but I'm going to assume that you all shouted out x minus 3. And so as long as we got a real simple, straightforward function, the inverse is actually very simple. Let's try a slightly more complicated one. Let's try f of x is 3x plus 5. And when you're thinking about functions, think about what you're doing to the number. It's a series of operations that you're performing on your input number. Here, whatever number we put in, we're going to triple and then add 5 to it. So if we were doing like f of 2, we get 3 times 2 plus 5. First, we would multiply by 2, and then we would add 5. We'll get 6 plus 5, which would be 11. Now, to undo this function, you want to think about the operations that you did to the number in the order that they were done. So here, the first thing we did was we multiplied by 3, and then we added 5. If we want to undo this function, we're going to need to undo these operations, but we're going to need to undo them in the opposite order that they were done. So if we want to start with our 11 and get our 2 back, we first need to take off that 5 that we added to it. So we'd subtract the 5 from 11. That would give us our 6. And then we divide by 3 to get our 2 back. Okay, so we're doing the opposite operations in the opposite order. So our inverse function here would be start with our input number, subtract 5, and then divide by 3. Divide the whole result by 3, not just the x. Let's look at a slightly different way to think about that too. I prefer to think about it this way, but it doesn't work in all situations. It does work in all situations I'm going to expect you to deal with. The way the textbook is going to tell you to do this, and it's not a bad way to think of it, is think of this as y equals 3x plus 5. And then swap the x and the y. So everywhere we have a y, we put an x. Everywhere we have an x, we put a y. And then we solve. So if I want to get my y alone, solve for y, so rearrange it so the y is alone, I would subtract 5 from both sides. And then I would divide both sides by 3. And that would give me my y equals x minus 5 over 3, which is the same thing we got doing it the other way. I think the other way is a little easier, so I'm going to stick with that. I'm not going to give anything more difficult than this one here. Suppose we get f of x equals 3x plus 4 over 2. What are the operations we're doing to x? We're multiplying by 3, then we're adding 4, and then we're dividing by 2. We want to undo those operations in the opposite order. We'd want to multiply by 2, then subtract 4, and then divide by 3. That would give us our inverse. So our inverse here is multiply the x by 2, subtract the 4, and then divide by 3. And we can check if we want to put a number in here, if we want to do f of 2, let's do f of 6, just so we don't get that 2 and the other 2 confused. If we put a 6 in there, we get 3 times 6 is 18, plus 4 is 22, divided by 2 gives us 11. If we put our 11 in here, f inverse of our 11, we'll get 2 times 11, which is 22, minus 4, which is 18, all divided by 3, which gives us our 6 back. Okay, that's how inverse functions work. Whatever one function does to a number turns that 6 into an 11. Its inverse will take that 11 and give us our 6 back. All right, in the blue book, skip the last of the 4 problems. So just do the first 3. They're very much like the 3 we just did. And then you can head on to section 5.1 homework in my math lab. We did not cover composition of functions, so 5.1.3 in the blue book. Go ahead and skip that. See you next time.